Starting with polygons, you played that game where you shot a monkey, right? And what made things polygons? What are like characteristics of polygons? Because sometimes it said like which thing isn't a polygon, which thing is a polygon. John?
Circles are polygons because they have curves.
Yeah. So no curves. Okay. What else has to make a polygon, James?
It has to be closed.
And it has to be closed. Okay. So that's all. That's all we need to know. Like what is a polygon? The word poly means many, so like many sides, a shape of many sides. But it has to be closed, and it has to not have any curved sides. Like, so this is closed, but has a curved side, right? I mean, maybe that's not technically closed, right? What about this thing? Is this a polygon?
No, because that's you're gonna end it.
Yeah.
Yes.
Yeah, okay. So, just to get things straight. Now, I'm going to set up an exploration for us today. Now, we're not going to go anywhere. We're just going to explore our minds. So, here's what I want you to write down. You're going to make like a table. In your table, you're going to have a shape, a name, the number of sides, a number of triangles, and a sum of degrees. So these are the things we're gonna set up. You know how we've done before, where I like I'm gonna try to draw some straight lines here. You know how before we've set up like we establish a pattern kind of thing.
Oh, this is straight lines.
I'm just really good at drawing straight lines, Tanya.
No.
It's not like my app has a tool for it or something.
Oh yeah, definitely not.
Okay, so we've got shape, name, sides, triangles, and the sum of our degrees. Let's start with the littlest polygon of them all. What is it? What is it, Lauren? The littlest polygon of all the polygons. The fewest number of sides to make a closed figure. Triangle. Okay, so here's the shape. Triangle literally means three angles. What's the name of this thing? I think we already a triangle. The name is called the Illuminati. You know what I mean? Okay, anyway. How many sides in that thing? Three. How many triangles in that thing? One. And how many degrees are in a triangle? 180. It was even on your last quiz, remember? One angle is twice as much as the first angle, and the third angle is 20 more for a total of 180 degrees. All triangles are 180 degrees. Triangle something. Is that it? No, that's the problem. Yeah. Let me see if I can draw another straight. So there's a triangle.
So all angles of a triangle are acute?
No, you could have a right angle.
Oh, you could have.
You could have an obtuse angle. Yep. But no matter what, you can't have two obtuse angles in a triangle, right? You can't have two right angles in a triangle.
You could have three acute.
Yep.
You could have three right angles. You could have 66.
It wouldn't get back. You could have, yeah. Okay, anyway, what's the next shape on here, Tanya?
A square.
Yeah, I'm gonna go with.
Rhombus.
Well, I'm gonna draw a rectangle, but we're gonna use the more general term. Parallelogram.
Oh yeah.
No, because a square has to have 4 right angles and 4 equal sides. Just a review: the square has 4 right angles, 4 equal sides, opposite sides are parallel. A rectangle, opposite sides are parallel and equal with 4 right angles, but all 4 sides don't have to be the same. Yeah, quadrilateral is the most general. A parallelogram would have to have opposite sides be congruent and parallel. But yeah, maybe quadrilateral would have been the better word even. I like that more. So how many sides in this quadrilateral?
4.
Okay, so when we try to discern how many triangles are in the figure, we use one angle to start. So I'm going to start up here and draw to all the opposite angles I can. So how many triangles in this? 2. If each triangle is 180 degrees, how many degrees are in my quadrilateral? 360. What's another way to justify that, thinking about a square or rectangle? 90 degrees 4 times, right? Okay. And you can kind of imagine, if you went to that slanty looking parallelogram, if you like stretch a side, as some angles get bigger, some angles get smaller, but they would still total 360. Okay. Next shape, what is it? Amelia.
Pentagon.
Okay, I just can't hear.
I don't know.
So I went 3 sides, 4 sides. pentagon. Thank you. So,
So are you just skipping rhombus?
no, rhombus is a quadrilateral. It'd be the same.
Oh, did.
Okay.
You're right.
Oh,
So,
Susie,
yeah.
we cannot see the screen.
Uh-oh. Okay, I got you.
Have you not been screen sharing this whole time?
Maybe not.
What, have you been recorded?
All right, let's see. How are we now?
That's good, thank you.
All right, sorry about that. All right, so
They could have said something.
here we go. So now we're on the pentagon. Ways to remember the pentagon. There's a place called the Pentagon for 5 branches of the military. Isn't there some group called like pentatonics?
Yeah.
And there's 5 people in the group.
Yeah.
Okay.
Like big Star Wars.
So this is a pentagon. Oh, I keep forgetting. Okay, there we go. Pentagon.
5 sides.
How many sides up in here?
5.
Okay, and if I draw from one angle to the others, I get 3 triangles.
Oh.
If each triangle is 180,
It's
540.
5.
It's a good day to be a skateboarder or someone that likes to do spins and know how many halves equals your spins. Okay, we're going to do one more together, and then I'm going to give you something a little bit challenging.
Wait, what's a hexagon? It's
If there's 6 sides, what's it called?
hexagon. Hexagon? Let's try.
Hexagon.
Does it
6
need to be
sides.
perfect?
Okay, so I'm going to draw in from my angles. How many triangles in my hexagon?
4.
If each triangle is 180, 720. Awesome. So I'm going to hope and think that you are going to be able to look at this and establish some patterns. Because here's what I want you to jump to. Don't draw the picture.
it adds 180.
I want you to jump to a pentagon, and I want you to give me a rule.
You mean polygon?
I messed that up. I got you.
Is it polygon? I got you.
Decagon is what I meant.
Oh,
yeah.
Okay, so I want you to jump to a decagon, and I want you to establish a rule that'll work for any gon. Okay?
I don't know what a decagon is.
So converse with people around you. Zoomers, I'll open that breakout room back out in a second here. All right? So a decagon, what is it? Jump to it, and I want you to try to establish a rule that you could use for any polygon to get the sum of the interior angles. I had a really good conversation with Amelia back there. So I'm going to Amelia here. I know there's lots of good conversation, right? I've got a whole class of kids. I love the hype. I love the excitement. Amelia told me that she noticed something. What did you notice, Amelia? Yeah, so I'm going to re-say it for my Zoomer. She said she noticed that if we looked at the sides, if we subtracted 2, it always gave us the number of triangles. Which means in my pentagon, Lily, how many triangles would I have?
You mean decagon?
That's what I mean. I don't know why I keep saying pentagon.
8.
I'd have 8 in my decagon. Okay. And then, Drew, we took it next level and said we already know what? Each triangle has how many degrees? 180. So, Mikey, 8 triangles of 180 would give us a total of what?
1440.
180.
1,440 degrees.
Oh.
Okay. Okay. The knowledge here that I want you to transfer to what we're about to do is, I think we can all say, we understand if we take the number of sides of a polygon and subtract 2, that gives us the number of triangles. And each triangle is 180 degrees, right? That's understanding. Just so you guys know, any other people came up with that same rule, right? I heard it around the classroom. I heard it louder from some people than others. But
No, it's 1660.
no, that's 1440 should be.
Okay, good. I got it.
So that is an equation. So follow me this next step to make it an equation. So if I want to generalize and say the number of sides minus 2, I would write that as n minus 2. The number of sides of the polygon minus 2 would give me what?
Equals sides. The amount of triangles.
The amount of triangles. But in each triangle is 180. So this equation would give me the sum of the interior angles of any polygon. Notice, is a two-sided figure a polygon? Notice what would happen if I threw 2 in there.
It's not close.
What 2 minus 2 is?
It would be 0.
It'd be 0. You can't do it, right? Cool. It works for anything. The reason you want to know this is, okay, you extend a pattern in that chart maybe, and I say, notice my polygon has 350 sides. You don't want to be extending a pattern to 350. You want to rule, right? Well, 348 times 180 gets you there, right? So the number of sides minus 2 times 180. Now, let's look at we're going to go with an octagon, and I'm going to use this word regular.
Irregular.
Okay, a regular octagon, which mine's not going to be drawn real great, would mean all sides are congruent.
It's not closed.
It's technically closed, okay? Just trust me. And all angles would be the same. That's what, when you see polygon in the word regular, that's what that means. Okay? So if all angles are equal, so this would be, this right here alone would give me the sum of interior angles. But what happens if I just want to know what this one little angle is? What if I just want one of the regular, John?
Then you could divide it by the number of angles.
Yeah, so if the total is the number of sides minus 2 times 180, if I divide that by the number of sides, that would give me just one of those angles. So the reason I point this out is when I was in school, I learned and memorized these. By the way, memorizing this is junk. I learned and memorized these as 2 separate equations that did 2 things. Does this second equation take any different understanding?
No.
No. This would give us
-2.
one angle, right? Give us just one angle. The way I'm going to encourage you to stash this upstairs is by the understanding that you can get the number of triangles in a figure by taking the sides minus 2, and each triangle is 180. That's what's up here. That understanding brings me to this equation. And if you understand it to bring it to the equation, you're going to be way better at recalling this later than just trying to remember n minus 2 times 180, right?
So what is the n? The n is
The number of sides, which is also the number of angles, right? By the way, you guys might not remember this, but on your expressions homework from like first unit, you had a question that said, if the sum of the interior angles equation is n minus 2 times 180, and it's an octagon, you did a substitution problem with this, and you just didn't even know it. First
That's
unit.
smart.
Yeah. Well, you might be surprised what you can do sometimes. Because I gave you the assignment, Will, so I remember that. Okay, anyway. So, this is all of the new stuff for today. On homework today, you're still going to practice naming your angles when we have parallel lines in a transversal. Again, the first question to ask yourself is what?
What do you know?
What do I know about this? If you start with what do I do, it's not going to go as well, trust me. Because every time someone's had a hiccup in class and I went to help them, if we just frame it in the what do you know, they come up with the what to do every time. I've actually had to not help anybody with anything except change their mindset on their approach, all right? So get after it. It's on Go Formative.